Okay, so this is the public cloud DevOps team. We're going to talk about the projects the public cloud team is working on, what we've got planned upcoming, how we work, what we like to work on, and why we actually do the things we do. And then at the end, we're going to talk about the new lifecycle that was published a little while ago that's changed a little bit, and how we're modifying the lifecycle to accommodate some of the changes and how SUSE supports SLES for SAP. So starting off, oh, well, before we get there, I'm Ron Noonan, by the way. I didn't put my name up there for plausible deniability. And this is?
I'm Robert Schweikert. I'm distinguished architect and the technical team lead of the public cloud team at SUSE.
So he's the engineer. That's why he doesn't really have shoes on. I'm the product manager, so I'm wearing a coat.
And so please fill out your evaluation after the talk, or you can do it now and give us all 5 stars. But you do get points for the Win a Fancy Prize on Thursday, and also we do have a booth in the showcase. So tonight during the booth crawl, come and visit us, drink a beer with us, and talk about public cloud.
Yes. Did they tell you to say that?
No.
Oh, okay.
I came up with that all by myself,
Excellent.
Which is quite amazing, isn't it?
What drives the public cloud projects? There are a couple of things that I just want to call out that's just basic work that you'll see happen in the public cloud for the target CSPs all of the time. The target CSPs being AWS, Azure, and Google, and then you'll see added this year is Oracle. Every existing image that's up on the public cloud environment today, we will be revving with new, every time there's a point release or a service pack, you will expect to see those images revved. And if they're pay-as-you-go images or on BYOS images, you'll see those revved. If they're BYOS images only, you'll see those revved. But by and large, the standard model is as new things come out from SUSE, we will rev the public cloud environments with that. That's the general policy. We also modify and work on images and create new components for images when the platforms on the CSPs change and we need to accommodate new things. I think recently you were talking about doing, or we just did stuff for encryption, and that's an example. So,
yeah. So the public cloud providers, add new services all the time. So one of them is, encryption, for example, on the OS disk in Azure. So we're working actively with Microsoft to support that for SLES. In Amazon, for example, there's, continuous evolution of the network infrastructure. And a few years ago, Amazon introduced what is known as the ENA driver into the Linux upstream kernel. And as their network infrastructure evolves, that driver gets new features. And so we incorporate those new features on more or less on a rolling basis as it gets incorporated into the upstream kernel. And then we backport it into the kernel version that is in SUSE Linux Enterprise Server and SUSE Linux Enterprise Server for SAP, so that the images always perform at their best, in the respective framework.
Yeah. And then one other area that we call out is we are adding new products and new capabilities as SUSE expands the scope of products that we make as a company and the presence that we have in the public cloud. We will be adding more images and things that are not images, but that we will talk a little bit about that in a bit. Things that we are going to be adding to the environment, new products that span images that are not AMIs per se or machine images, but actual mesh installs. So you'll see those things also driving the thing. There's one other area that's down here that we don't talk about that much, but we also do a lot of updates to the infrastructure, and that's some of the buckets of work that you'll see. And we will call that out today in one specific project. Yeah, go ahead.
Ask questions as you go.
Are all these deployments with SAP or is another application?
So the question is if all the deployments are with SAP, so the SAP application suite. Okay, so no. So we have 2 products. So there's SLES, SUSE Linux Enterprise Server, and there's SUSE Linux Enterprise Server for SAP. So SUSE Linux Enterprise Server for SAP is primarily used with SAP applications, but SUSE Linux Enterprise Server is used for any workload and any application that you find in a data center. And we don't necessarily have insight into what customers of SUSE Linux Enterprise Server use the OS or the image for. but they do HPC. Some decide not to use the database service from the public cloud providers, but they run their own database, and then they may use less for that. And there's really everything under the sun that runs on SLES in the data center also runs on SLES in the public cloud.
Yeah, I think for a driver from that, a lot of companies, and we're working with many of them directly, so a lot of them are taking their on-prem workloads and moving them into the public cloud. And if it's not an SAP application, they still want to move some of that stuff. And when they do that, they're trying to move it up and keep the stack as whole as they can.
Yeah, we don't have visibility. I mean, sometimes we hear it through sales engineering or
We have the numbers, actually.
or, but we can't tell you, okay, we have, this specific application. So SUSE has a certified application catalog of nearly 10,000 applications that run on SUSE Enterprise Server. And so we don't know which customer is running which of those 10,000 applications in detail.
So could I just maybe clarify so I understand? Are you asking would applications run aside from SLES for SAP? Or are you asking how many SLES versus SLES for SAP?
No, the application layer.
Answer that second question because it would be very hard for, I don't know if it's logistics or SUSE cannot provide that detail, but what other applications beyond SAP
Drive the use.
drive SUSE's
Yeah.
Yeah,
Okay.
we don't,
Got it.
I mean, there's a
That's-
10,000 application catalog, 10,000 applications
We
are
don't have all of that
certified,
detail,
and we don't know.
Yeah.
Can be anything from, HPC applications that do crash analysis to
Yeah.
financial applications, and we don't know. And there are also a lot of applications that are not certified, that are in-house applications that are written by customers, and of those, we don't know, right?
So looking for how would you bring differentiation with, like, say, suppose your competitor, right, with these cloud service providers.
Yeah.
Well, from a differentiation standpoint, I think some of the infrastructure we supply and some of the just more macro things we do is probably one of the things we could talk to. As far as application sets, no, and a lot of them are line of business. I could name just esoteric ones, like one's a giant bottling application. It's probably the only one, but it's huge. So last year, there were 90 plus unique images that were released in the public cloud frameworks across Google, Azure, and AWS. 272 servers are used to keep that update infrastructure running and supply those things. And actually, Robert's going to go into details with some fuzzy pictures in a little bit about actually what that looks like today and what it's going to look like in the near future. And of those 272 servers and those 90 plus images across the three frameworks, that was up last year without any downtime. And that's the environment that we cater to and we use. And the no downtime is one of the things that the high availability of the images, the rapid download speeds, the local nature of them, and the HA style of implementation are some of the things that we do to try to make sure that a public cloud experience is very high.
Yes, go ahead.
Are you supporting live kernel patching in the cloud?
So live kernel patching, so the question is whether we support live kernel patching in the cloud images. So live kernel patching is an add-on product, and add-on products are currently only supported for bring your own subscription instances. So the answer is yes, if you use bring your own subscription instances.
And so bring your own subscription also means bring your own image? Or
No.
No.
So we have pre-built bring your own subscription images. So if you go back a slide, Ron. So here you can see we have bring your own subscription and pay as you go images, and these are available in all three major cloud platforms. And so bring your own subscription means you use one of our images that is pre-configured to bring your own subscription. So you're paying the base rate for the instance type that you're using to the cloud provider, and you're using the entitlement that you have from SUSE. And when you go that direction, that means you also get to call SUSE support directly and say, hey, I'm running a BYOS instance in cloud XYZ, and I need L3 support. So that comes along with BYOS. And when you have that, then you can also use live patching and all of that. So
Engineering answer. product management question. What do you need?
No, that's the same thing we do.
Oh, it is? Okay. Okay.
I just want to see if there's anything.
All right.
So just as a follow-on to that, there are also customers, partners out there who do bring their own image. They do their own image.
Well, yes, you can. Of course, you can bring your own image.
Yeah.
Right.
And I don't think I don't know if we differentiate that or know about those necessarily.
Actually, we're building systems to start tracking that, but they do not exist right now. They're not implemented, I should say. So actually, this is a slide that helps you talk to the BYOS and the on-demand and all.
Right.
So these are the AWS images that are out there from last year that were put out from EC2, SLES 12 images, SLES 12 for SAP, 11, 15, and some others. And if you look through the list, it's not very big, but you can see some of these are on demand, which are the pay-as-you-go. There's a BYOS image, which is an image that's provided by us that's loaded up on the cloud. And so these are what we've done for AWS in the last year. We have the same thing. Here's what we've done in the Azure space. You'll see the same sets of images, different names, and then Google's environment.
Yep.
And then some other stuff that's not SLES based or SUSE
Yep.
Manager, BYOS images for SUSE Manager on the various platforms. And this is brand new,
Oracle. Yep.
being announced right now. Oracle has OCI is a bring your own environment that they've asked us to build images for, and they made a good enough business case that someone said yes, and hey, we've got images for them now. And so these are coming out in the very, very near future, and they've just been announced. And so it's really focused on SLES and SLES for SAP, which someone should ask, SLES for SAP and Oracle, but yes, they do want that. They're very big competitors. Okay, images. This is more or less what drives a lot of the activity that was in that first box. Every time we have a new release of product, we come out with a new image that reflects that release. So you see SLES 12, SP5, SLES 15, SP1. The team works on those images as those products are being developed by the product teams and build the automated scripts so that the internal systems, actually, why don't you describe that? So you go through the work process, you build it up, so every time something builds, it builds as part of the product set.
Yeah, so when we build the images, we create an image description, and then just like all the packages for SUSE are built in the build service that you may have heard about, all our images are also built in the build service. So there's a very tight connection. Every time a package changes in the product, the images get rebuilt, and we're working on a pipeline to then automatically push those images into the respective clouds and run an automated testing. So there's a CI/CD pipeline that is in the process of being rolled out, where basically everything that pops out as an image gets tested. So we're continuously working on improving, what is available to you that you can download. And that, we'll talk about this some more when we get to the life cycle discussion. And you can see the different images, and for every image that we have, the goal is that we are always available on FCS date, which is first customer ship. So when you can download the ISO from download.suse.com, on that same day, you will see an image in the cloud frameworks. So that is the goal, and for SLES for SAP, for SUSE Manager, we're there, and then some of the others are, we're still in the process of getting that release cycle synchronized.
So that's really what drives a lot of the activity, and that's the run rate work that it equates to what's, well, there may be one exception down here. You call it out.
So SLES for HPC in Azure, we're working very closely with Microsoft. The technology that we've been using in the past, basically there's an out-of-tree kernel driver, and everybody who has ever listened to Greg Kroah-Hartman or Linus Torvalds or anybody of the top kernel developers, what do they say? don't keep drivers outside of the tree because you can't keep up. And that's basically one of the things that we're working with Microsoft, and Microsoft has done a tremendous job. They're changing the technology. Things are going upstream in the kernel. We're going to have PCI pass-through, and then all of this out-of-kernel tree funny business is going away, and then we're going to get to the point where HPC images are also going to be released on first customer ship day. So right now we're working, through, there's SUSE offers a service that is called the Solid Driver program. And in that Solid Driver program, we're building the out-of-tree kernel, and then we're pulling that into the images and trying to get them out the door. And that is all, not necessarily nicely integrated on our end. So, and yes, AWS is coming. Plus for HPC, and AWS is also in the works. There are also some drivers that need to go upstream and also user space, and we're working with AWS to get that pipeline finished and get the new drivers for the kernel upstream and get OpenMPI and libIB updated in SLES so that we can take full advantage of RDMA in AWS as well.
Thank you. So here's some of the new stuff, and you see, so actually a couple of these things just finished. So the Azure large image, that's something that's been ongoing, a project with Microsoft and Robert's team, or Robert and others, and that has been a big process, and those are for SAP environments, and we describe really how big they are.
Yeah, so the Azure large instances and very large instances, that's actually a hosted environment that's provided by Microsoft. They run on Cisco systems and HP really large systems, I don't remember the name. And in conjunction with Microsoft, we developed the design for the backend to provide us data. So these are hardware instances, so this is not, ooh, I'm going to click a button and some virtual machine starts. So this is a deployment of a pre-built image without any installation, but that still has to be customized. And so this is where we work closely with Microsoft to design what the data format should look like and how we're going to ingest the data from a hardware instance to then fully deploy a pre-built image, partition the disk, set up the network, and all of that. All of our part, the initialization of that image, once it's pushed out, is open source. And Microsoft is working on their part to basically create a configuration that we can then ingest and customize the installation of, well, I don't want to say installation because it's really in deployment. So this is not AutoYAS. This is a fully built image that just gets customized for host name, user setup, network configuration, disk partitions, things like that.
Did you want to touch on how big they are, or Steve, if you want to say how big they are? Because I had some people query me and say, can you really actually be Intel and be that big? Because it doesn't seem right. So the very large, so then there's the AWS A1 image support. Those actually just got completed, so those are ARM images, and they are now available and completed. That's something new from AWS that was announced at reInvent. And we have now completed those ARM instances, and you can get them.
Yeah, and as of last Saturday, they're available in the Quick Launcher, and you can launch them right from there, and those are on demand, and then there's bring your own subscription as well for the ARM instances. Yeah. And we're working on integrating, making ARM instances that integrate with ECS available as well. So. Yeah.
And the Oracle instances, OCI, we pointed that out. So that's a little different. It doesn't use an update infrastructure. They're BYOS only. It's the way they operate. But they are a very big application shop. They want to support these images, and they have a large environment now where they support their applications, and they also support SAP applications. And so that's new, and that will be out, well, it says Q2, but that's because I wanted to be safe in the date I put there. But it's being announced right now, and they're just about done. SLES EKS worker nodes, that's actually a pretty interesting project on AWS. You want to talk about what that is?
Yeah, so EKS is Kubernetes hosted environment by Amazon. So Amazon hosts the control plane of the Kubernetes cluster, and then they provide hooks for partners such as SUSE to provide an image that will automatically integrate with the host, with the Kubernetes hosted control plane. And so there's, CNI, which is cloud network interfacing, and some other packages that need to be integrated into SUSE Linux Enterprise Server in order to make that interaction smoothly and seamless. And then basically from the AWS UI, you can then, when we're there, you can select SUSE Linux Enterprise Server, which will be a specific image built that integrates seamlessly into the EKS hosted control plane into the EKS service from AWS.
And maybe I should just take a quick second to define. EKS is Amazon's managed Kubernetes service that they offer. That's a turnkey solution for running Kubernetes on their platform. And these worker nodes then are embedded operating system images into that environment. Azure tuned kernel, this is actually something that's specific that Microsoft does, where offer a special kernel that's unique to their platform that we work with them directly on. And again, you want to go through the process because it's pretty fascinating. And Steve there and Robert, they work together with the labs team quite closely.
Yeah, so for the Azure tuned kernel, basically, so SUSE Linux Enterprise Server promised no changes for kernel ABI, which makes the kernel move rather slowly. And Microsoft, we had a conversation a couple years ago at SUSECON, and the question was, so how can we make the kernel move faster, right? Mm-hmm. And especially as I mentioned earlier, cloud platforms continually evolve quickly. And so the answer was, okay, if we want to go faster and incorporate new features to help make things better on Azure, on Hyper-V, we're going to have to let go of the kernel ABI. So that was the trade-off. So basically, the Azure kernel makes no promises with respect to kernel ABI changes within one service pack. And so because of that, it allows us to basically integrate things from upstream faster that may potentially break the kernel ABI. And that's okay because we know this happens for Azure and it's targeted for the Azure platform. But that doesn't mean that you have to use that kernel, right? So if you have an application that is sensitive to the kernel ABI, you can easily switch back to the default kernel. That means you may pay, with maybe network performance or disk performance, depends on what we just integrated, but you get that kernel ABI stability. But for many applications, that doesn't matter. They don't care what the kernel ABI is, right? And they just want to go fast. And so for those use cases, the Azure kernel is your ticket to getting new features into the kernel that enable SLES to run. It's mostly centered around performance, so it allows us to run faster and take better advantage of what Hyper-V provides to the guest.
You're doing the same testing, though?
Yes, it's the same testing. There's testing in conjunction with Microsoft. So we're sharing a project or a storage container with Microsoft where we basically put the images with the latest Azure kernel, and then Microsoft picks it up and runs it through the whole test suite. So there's full vetting and full testing, and the Azure kernel is fully supported by SUSE for the life cycle of that service pack.
Which we will cover in a few more slides.
Yep.
So, yes.
So how do you define an Azure kernel? Is it a feature requested by Microsoft?
Yes. So there's an agreed process between Microsoft and SUSE. We have a stripped down configuration of the kernel, so that's the first thing. So the kernel is smaller than the default kernel. And then basically Microsoft files a bug for SUSE and says, here are the patches that were integrated upstream that do X, Y, Z, make the kernel faster or fix a bug. Please integrate them. And then we integrate those patches, we pull them from upstream, and then we go through the QA cycle, and then it gets released. And then we release new images that have that new kernel.
It's not rebasing this kernel,
Yeah, so
Yeah.
this is focused on the kernel. So this initiative does not include any changes in user space. This is only
Yeah.
the kernel.
Yeah.
Yeah.
Yeah. And it's really driven by the changes that Microsoft wants.
Yeah.
So Cloud Application Platform, this is something that's new, and this is a project that was going to kick off next week that accidentally kicked off last week. The engineering got excited. So what we want to do is, and Cloud Application Platform is the Kubernetes-based Cloud Foundry implementation that we have. And so it's a solution set that installs into a Kubernetes environment and gives you the controls and workflow of Cloud Foundry, but it actually deploys the applications and makes them native Kubernetes applications. It's a very interesting technology, and it installs and runs in AKS and EKS and GKE, and then a number of other Kubernetes environments. But for AKS, EKS, and GKE, we are going to start building a one-click install so that you press a button up on the marketplace or wherever on the respective frameworks, and it's going to provision an HA-based production-ready environment, stand it up for you. It's going to stand up the clusters for you based on some answers that you give it, and it will then deploy the Cloud Application Platform into those clusters and install it into that across,
You're
well,
going to sleep.
oh yeah, thanks. I was getting tired, and I thought it was just getting darker. And so it will then provide that, it'll provision, it'll install Cloud Application Platform, and it'll then set up the service brokers for the environment, for the integrated framework brokers, and make it a turnkey documented solution. So it's more or less a reference architecture that's production ready, that will be produced in the same way that we do, kind of the way Robert described the SLE implementations, in that every time we do a new build of Cloud Application Platform, the engineering teams will actually have this process spit out a new version of that reference architecture. So all of the frameworks have a current implementation of the stack implemented in an easy way for people to try it. And that when you shut it down, thanks to some good feedback from David yesterday, we're going to make sure that everything you do undoes so that there's no legacy things running. But, so that's one of the projects that's kicking off right now. And we hope to have that done summer, but I put Q3 up there just to be safe. So that's actually an exciting project. That's a fun one. Infrastructure updates. This is, I'll let you talk to it, but then we're going to have the big one. That's a few slides.
Yeah,
after
so this is just very quickly. So, we're still working on full IPv6 support. So currently you can access the update infrastructure only over IPv4, which is not a bad thing because every cloud framework provider still, if you're using IPv6, is still required to run a dual stack. There's no pure IPv6 only. So, so we still have some time before we're getting to IPv6 only, but we're working on preparing for when that day comes. So there's still some work to do for us, but we're moving in that direction, and sometime in the next couple of months, we're going to start on this major infrastructure update, which we're going to talk more in detail
right now.
right now. So this is what this looks like today. So provider framework means any provider where we operate the update infrastructure, and the update infrastructure is always region local. So within any framework, we have what we call region servers, and those region servers basically know where the update servers are and how the update servers can be reached. And these update servers, there are basically, currently there are 2, but there could be more, but there are 2 currently in each region for each product. So there are 2 for SLES, and there are 2 for SLES for SAP. And that brings with it various disadvantages. And so what happens is that when a on-demand image or instance gets created, that guest, as I pointed out here, goes out to the region server and says, hey, where should I go for my updates, right? And then the region server sends information back, and then that guest registers with the update infrastructure to get the updates. And all of that is region local.
You ready? There you go.
Yep. And so this is what we're going to next. Basically, we're going to have three update servers by default in every region. And the good news is no more separation between SLES and SLES for SAP. And now that we're going to have three, we also have better HA setup. So currently we only have two per product. So that means when one goes down, then there's only one serving the rest of the world, right? And so HA is really, you always want to have three. And so we're going to that to have three, and both of them have, and all three will have all the products on there. And, but the communication path and everything stay the same. Yeah. And so this is new technology that is getting deployed. Everything is going to be basically revamped, and nobody's going to notice.
The reality is you don't see this unless something doesn't happen.
Exactly.
So
yeah. And so here again, so this is the way it works today, and this is the way it's going to work going forward, right? The guest image goes out to the region server, and the region server sends back information to where the update server can be found, and then the guest goes to the update server and says, hey, give me your repositories. So this is not going to change. This is the same. This is going to be the same in the new update infrastructure as it is in the current infrastructure. So the communication path stays exactly the same. But so why are we doing all of this? Well, first of all, as I mentioned, we can now finally put all the products on the same update server. So that means for SUSE, for my team, where there are two sysadmins, we have, for now, we will have fewer servers to operate, right? As the cloud framework providers grow, we get new regions all the time. We're going to eventually end up with the same number of servers that we have today. But for now, we're going to have fewer servers to operate. Also, we're going to have failover across more servers. So that means we have better HA. That means, in the end, we can provide better service to you, our customers, right? And we have many customers that whitelist the egress pattern, so they run in a private network in the cloud framework. So in AWS and Google, it's called the VPC, and in Azure, it's called the VNet. And many customers seal those off to the outside world. And so today, what they have to do is basically they have to whitelist the IP addresses for our update servers, and those are published. And then they go and say, okay, I have to whitelist the IP addresses for the region servers, and they have to whitelist the IP addresses for the SLES update servers and the SLES for SAP update servers. And so because SLES and SLES for SAP merges, it makes it easier for them to whitelist. They don't have to worry about it. Also, from a network separation perspective, it's now easier for them to run SLES and SLES for SAP in the same network, again, because all the servers will have all the products, right? So this is an advantage to those customers.
I'll add one more, and that is as we get new products, like SLES 15 HPC became a new product,
right?
The ability to add new products in this new model, the barrier to entry to add another product is no longer so high, because we don't have to stand up an entire set of new servers. We can add it to the existing set. Yeah. That's actually a proper HA setup.
Right. And with this new update infrastructure, eventually, not right away, but eventually, we will also be able to support this data path. So today, we cannot support this data path, period. And we get many customers that ask us, okay, so why can I not send my traffic from this SLES instance in the public cloud through my data center that meets all my security rules and firewall rules and whatever else, and then send it back to the update server? Because when the data comes this way today, that data path gets rejected, because as far as we're concerned, the traffic does not really originate in the public cloud. It originates from here because that's what we see, right? Once we have this new update infrastructure in place, and there's some other things that we have to do, we will eventually be able later this year to support this data path. So then customers can go and send from cloud through their private link or whatever dedicated connection they may have, and then send it back to our update servers, and they'll get their updates. And without necessarily whitelisting the egress rules in the VPC, so they can then take advantage of that data path. So that's actually that's a request we get quite often, and we'll be able to fulfill that later on this year.
So we're going to switch gears and talk about the new lifecycle that we just republished. So we've had a lifecycle up there, which the public cloud images have a different lifecycle than standard on-prem lifecycles, and that's going to be covered here. This is the new lifecycle. So I'll just cover this, and I'll let Robert dive in because he likes to talk about the detail. So the active images, we have 4 categories of images. We have active images, which are the images that are live, that are the new images that you can actually have out there, and then they have a 3-month rolling cycle, and we'll talk more about that in a minute. And the inactive images is the next stage that an image goes through. It's going to basically roll through inactive and then deprecated and deleted. And then the rules that each one of them goes through we'll talk about, and how it actually operates in the life cycle. So I'm actually in the next slide, go through that. So let's start with the rolling life cycle and go through that. So
Okay. Yeah, so the rolling refresh cycle basically means that every 3 months, on a rolling basis, we update the active images. So what does rolling mean? Rolling means that we're not on a set schedule, but the schedule is triggered by events. So probably best to go through an example. So let's say we release images on May 1st. And if there's no security incident or anything, then 3 months later we would refresh the images. So then we're on that 3-month cycle, right? So in this example, let's say we release on May 1st, and then on June 15th, there's a major security issue. So think Heartbleed, Spectre, Shell Shock, Poodle, you name any of the buzzwords that came across your security radar over the last couple of years. Think about those, and then every time when that happens, we refresh our images when the fix is available. Okay. So if we were to release an image on May 1st, and then on June 15th a major disclosure happens, then our images would get refreshed with that, and that resets the refresh clock, right? So then the refresh clock gets set to 0 on June 15th, and so therefore the next refresh would be September 15, right? So as opposed to having 2 months after. So that's the rolling refresh cycle. So whenever there is an incident, when we refresh the images, that would be out of band refresh, then that regular clock of 3 months resets. And so that's the rolling refresh cycle. And so the refresh cycle applies to anything that's active for on-demand and bring your own subscription. And for on-demand, what we basically consider, so critical security issues, obviously, and then things that, affect the instance function. So, let's say we released an image and instances get created and something may change on the platform or whatever. And we figure out, oh, hey, at a rate of 15%, something silly happens and we can't register or whatever, and we can trace that back. Then we would fix that bug, and then we would refresh the images so that we get rid of that problem, right? So that would be for on-demand images. And then update availability. So that means, how can I pull updates that we release that come from the update infrastructure?
I did that. So.
Yep. One more, 2 more.
Yeah.
Yep. All right. So updates are available for, they come from the update infrastructure, and they're available for images in inactive, inactive, and deprecated states. So those images are registered, and just think of the update infrastructure like a mini SCC, SUSE Customer Center. So as long as the product team keeps feeding updates into the channels, that's how long they will be available to your instances. Once we reach the deprecation period, then no updates are are available anymore. So that follows the upstream product life cycle, basically. The state transitions between from active to inactive and from inactive to deprecated or from active to deprecated are defined based on the product life cycle. So for SLES, for SUSE Linux Enterprise Server, that means when a new service pack gets released, then the current image of the previous service pack goes into deprecated state immediately, because the deprecated state is defined as 6 months, and which is exactly the overlap period of SUSE Linux Enterprise Server. Okay, so SUSE Linux Enterprise Server, the next service pack for SLES 12 is SLES 12 SP5, which will be released sometime next year. And when that happens, then the SLES 12 SP4 image goes from active immediately to deprecated. And that period lasts for 6 months, and then the image goes away. It gets deleted. And then you use the SLES 12 SP5. For SUSE Linux Enterprise Server for SAP applications, the process is different because last year we announced what is known as SPOS, or Extended Service Pack Overlap Support, where basically the overlap period is 3 years. And so when the new service pack is released, then SUSE Linux Enterprise Server goes immediately into the SPOS period, and that for us means the image goes into the inactive period. So it only gets refreshed for major security issues and for nothing else. And so that's the inactive period. And then 6 months before the extended service pack overlap support ends, the image goes into deprecated mode, so that you as a customer knows, okay, this image is coming to an end. How do you find all that out? We have a tool, it's called Pint.
Yeah.
And you can install a package called Python 3 SUSE Public Cloud Info, and then you can run Pint. And Pint is backed by a REST service, and that REST service delivers information of every image we have ever published in the public cloud. For Amazon, that goes back to 2010. I actually needed to look that up today for some reason. So I think it was March 21st in 2010 was when we published our first image in AWS, and it was SLES 11 SP1. And from there, if you look at the data, you can trace from that image all the way today to reach SLES 12 SP4 and SLES 15. So all that data is available. There's a REST API. And how to use the tool, there's a blog on the SUSE blog site.
Yeah. So, and all of this, I'm sure you have this memorized now because it's not that complicated. I know. So we're going to be putting up, now in our new independence, we're going to be standing up a web page that actually covers all of this. And so that's coming soon. But if you can't wait for that, Robert wrote a very nice anecdotally, and well, it's got lots of nice little stories in it, blog that actually covers all these points and gives examples. So if you look up on the SUSE blog site, you can find that under his name. But we will have this officially stated up on the SUSE.com site pretty soon.
Yep. Okay, and yeah, so SLES for SAP, we just covered.
Yeah.
Question on the last one.
Yeah.
Was there a comment on the final service pack, SLES for SAP?
Yeah, so the final service pack for SLES for SAP. So the question is about the final service pack for SLES for SAP. So when you're at the final service pack for SLES for SAP, obviously there is no overlap period because nothing else is coming. So in the last service pack for SLES for SAP, that image remains active until 6 months prior to end of life. And then it goes deprecated. Because at the end of life, then SLES for SAP goes into LTSs, so long-term service pack support. And long-term service pack support is not available for on-demand images, only available for bring your own subscription. So the bring your own subscription image will continue to be in inactive state after when the on-demand image goes end of life, the bring your own subscription will be in inactive state for the next 3 years, which covers the LTSs period.
So basically, these on-demand, the images up here on the public cloud match on-prem for the active and the SPOS, but they do not match it with the LTSs, essentially.
Yeah.
So we did cover this.
Yep. Yeah, we covered that.
And SLES for SAP, BYOS images actually allow you to do the LTSs.
Well, yeah, so
Yeah.
as I just mentioned, and so because of this life cycle change, what we actually did is we brought back some images that we already had pushed over the edge. But when the product team decided that we were going to extend the life cycle of SLES for SAP, that meant for us in the public cloud that SLES 12 for SAP Service Pack 1 came back to life. Which we cannot do, unfortunately, in AWS because of the network driver. So the ENA driver is not in the SLES 12 SP1 kernel, and the technology has diverged so far that we can't backport this, and so SLES 12 SP1 for SAP is not coming back in AWS. Because we could only give you a degraded network performance experience, and we don't want to do that. So that's not coming back. But SLES 12 SP2 for SAP, which has the new ENA driver in it, that has come back.
Yep, and then we'll follow the standard life cycle after that going forward. So this was just basically this new announcement is refreshing a bunch of images that had basically disappeared. And then once they're all back, everything will just start operating on this cycle going forward. And that is what we wanted to cover.
Yep.
Are there questions? Things
Now
that
we
are
have-
interesting?
Now we have time for additional questions.
The 3-month refresh cycle that you talked about, the 3-month refresh cycle?
Yeah.
Doesn't coincide with even the maintenance releases. What's driving that refresh?
So the question is, what's driving the 3-month refresh cycle? It's partially driven by the number of updates that get released, right? So what we want is, there are a lot of updates that get released. I mean, basically SLES is, despite it being an enterprise distribution, it actually moves quite fast. So there are bug fixes that go out in packages every day. Every day there's at least one package that gets released, sometimes more. And over the span of 3 months, that means there's a lot of packages that accumulate.
Yeah.
And so if a customer starts an instance that is from an image that's 3 months old, and then they run zipper up, well, they have to sit there and say, although it goes really fast with our update infrastructure, but in the end, you're paying your instances to run your workload, not to get updated, right? And so when we do the 3-month refresh cycle, we're basically shortening that time where you want for you to update the instance, right? So that is one big driving factor. The other big driving factor is that, you know, new developments that we're getting out, such as the ENA driver in AWS, the Azure kernel is on a 3-month refresh cycle, so that we get those out and we get new images, so you don't have to go in and say, okay, what version of this do I need now, and what version of that? So you know every 3 months you get this new technology that is being developed with our partners, and we get it out by default, right? So that you don't have to sit there and say, okay, did I get the latest thing from here or there? We want to take all of that away and make it easier for you. You know, that in the end is our goal. Yeah.
Yeah.
So.
And the product teams actually recommended that we use a quarterly update system.
Yeah. And also from SLES 15 SP1 forward, the SLES team will, so we have this, in SLES 15 we introduced a unified installer, and that unified installer will also get refreshed every 3 months. So from there we're then in sync with basically with the product team. So, although we don't need the installer in the public cloud, obviously, because you have pre-built installations that are ready to go.
But we also don't want to wait for updates.
Right. Any other questions? All right.
Thank
Thank you
you.
very much. Thanks for
Yeah.
your time.